Hello, welcome back to Algebra. In this lesson, we're going to cover the concept of what is a function. Now, in the last section, we talked about relations and functions in algebra and how they're very similar to one another and how a function is different from a relation. Now we're going to take and turn our attention specifically to the concept of a function. Because as I've mentioned before, functions are basically what you're going to use throughout algebra, throughout geometry, throughout calculus, physics, chemistry, engineering, pretty much any type of advanced learning that you're going to get into in learning is going to involve the concept of a function. So in this lesson, what I want to do is go a little bit deeper into what a function is, illustrate it for you, and give you some examples of very common functions that we will see as we get into more of our advanced study of algebra. So at the end of this, you should have an idea of what a function really is and examples of some common functions that we'll be using as we go along forward into the class. Now, I could write the definition down on the board, but honestly, it's very simple to understand it, so I'm just going to read it to you and then I'll draw a picture to illustrate it. A function in math or in algebra is a mathematical, I'm going to call it a machine, but you can think of it as a mathematical object, right? Or a construct that takes x values as the input to the machine, right? And it outputs y values, or we say f of x, functions of x. We call them for now y values. That's what we've been calling them up until this point, in a one-to-one correspondence. So what it means is you have a black box here. It's something that we call a function. The input to the machine is values that we call x, and it performs some functional operation, and the output on the other side is another number called y, what we call in a one-to-one correspondence. That means that there's only one value of y for every input value of x. And we talked about this a lot in the last section because relations in general are different. They can have more than one value of y for each value of x. But for functions, for every input you put in, you only get one output. That's what the basic difference is. So if we wanted to draw it, and we do want to draw it. I like drawing things, especially with this, because it makes it very easy to understand. So here we have a black box. We call it a machine, right? But what we're really saying is there's some kind of calculation in here. And inside of this, we're representing as the function f of x, right? Now this notation does not mean f multiplied by x. So you kind of have to reprogram yourself a little bit because it looks like f is multiplied by x. It doesn't mean that. It means f is some function. It's a function of x. So we put it in parentheses to show you that you're taking values of x and you're sticking them into the function. Now these values of x, where do they come from? Well, you feed those values in from the outside. And these are the x values. So you see you have numbers you're putting in, the x values, and then you operate on it on this function of x. That's why it's parentheses x. And the output comes out of the other side. So that's why we say this is a machine kind of. It takes these numbers and it does something to them, and then the output comes out the other end. And so I'll also say that this is the output values. And the outputs that come out are called f of x. But up until now, we've basically been using functions a lot, even though you haven't realized it. We've been talking about lines. And lines are functions, just like most objects in math that we're going to learn about are going to be functions. Well, you've already used one. It's called a line. That's a function of x. Remember, we stick the x value in and we get the y value out. So here's where we kind of have to take a step back and talk candidly with you a little bit, right? So a lot of students get confused when we talk about functions because we've been learning about lines. We learn y equals mx plus b, right? We take the value of x, we calculate the value of y, and then you get to this idea of a function, which is kind of the same thing. You're taking the value that's going in, you calculate something, and then out comes the value out. You see, what we were learning, this concept of functions now, it's exactly what you've already been doing. It's no real different. It's just a relabeling. Before we said that y is equal to mx plus b. Here we're just saying, instead of calling it y, we're going to say the output value is called f of x. This is the way you read it, f of x. It's a function of x. So everything that you've learned up until this point about lines specifically applies to functions. You take input values, you calculate output values. It's just that in the past, we always called those output values y. Here we're calling them f of x. So then you might say, why are we renaming them? That doesn't make a lot of sense. Well, it's because as you get more and more advanced math, there's a whole branch of mathematics called function theory that you kind of have to crawl before you walk. So when we first started, we talk about y is equal to mx plus b or whatever function that we have. We don't really talk about functions in the beginning because we're just getting you used to the idea of plotting things on graphs and so on and so forth. But as soon as you have that idea of a line under your belt, and you basically have already been dealing with your very first functions, which are called linear functions, that are lines, now we can take the training wheels off and say, hey, what you've been doing in the past is really a function. And so what it is, it's a mathematical machine. Inside the machine before, we've learned it's mx plus b. That's the function that you've been dealing with so far. But this function can be anything. It can be all kinds of things that we'll talk about as we go more and more through math, and we'll learn several of them here. But anyway, you take inputs, you calculate things, and you get outputs. All right, so let's do a couple of quick examples just to illustrate. So here's an example, right? Here's an example function. F of x is equal to 2x plus 3. Now you should recognize this because if I cover up the f of x part, and if I just put y equals 2x plus 3, what would it look like? You should recognize that this is a line, right? It has a y-intercept of 3, and it has a slope of 2, and we know how to calculate that. We can either plot the y-intercept and then do rise over run and draw the line. We can do that. But if it were y is equal to 2x plus 3, you also know that you can write a table. You can stick values of x into this place and calculate the corresponding y values. Now we're just relabeling everything, and we're saying we're not calling it y is equal to this anymore. We're saying f of x means this is a function of x, and this is what the function is equal to. Now this specific function is called a linear function. So now you're kind of grown up a little bit and you're studying and you start using fancy terms like linear function. Linear just means line, function means it's function. It means it takes an input and you get a single output out. There's a one-to-one correspondence for every input, you get one input out, only one. That's what a function is. And of course we talked about the vertical line test before because every time you draw that vertical line and it only intersects in one spot, you only have one output for every input. That's what a function is. So this is an example of a linear function. And if you wanted to graph this, it would be basically exactly what we did a long time ago when we started talking about lines. We can take the input values, and we can list them over here, and we can put a table with the output values. So we put the input values of x into the machine, and we take the output values as we calculate them on the output side. And then we're going to have x, y points. Although we don't call them x and y anymore, we call them x and f of x, but you plot them as x and y as we always have. So we can, for instance, take -2 as an input, -1, 0, 1, and 2. And of course we can go on from negative infinity to positive infinity, calculating values until we're blue in the face. So how do you calculate this? You take the -2 into the function, which means you put it into the value of x, which means what you have here is the way you write it is f of -2 means you're taking -2 and you're sticking it into the function. This does not mean f times 2 or f times -2. It doesn't mean this is multiplied. This means that we take the -2, we stick it into the function, which means we substitute it into the position where x is. So we have 2 times -2 plus 3. So what do we have here? This is -4 plus 3. What do we have here? -1. Right? That's what we get for the first value. And then for the next value, we can say, all right, let's take f, and we'll stick -1 in. So it's f of -1. That's how you say it out loud. So it'd be 2 times sticking -1 in here, plus 3. This is going to be -2 plus 3. And what do you get here? You get 1 for the second value. All right? And then for the third value, we're plugging in a value of 0. So it's f evaluated at 0, or f of 0, is equal to 2 times 0 plus 3. This is going to give you 0 plus 3, so we can just write 3 down. That's the easiest way to write that. And then we can now evaluate it, x is equal to 1. So we say f of 1 is 2 times 1 plus 3. So here you have 2 plus 3 is 5. And the last one, f evaluated at 2, we read it as f of 2. 2 times 2 plus 3. This is 4 plus 3 is 7. So I can kind of shortcut a little bit there. So you have -1, 1, 3, 5, and 7. What do you think this is going to look like when you plot it? I mean, you already know it's going to be a line, but just for completeness, Let's go ahead and quickly draw it real quick. We're not going to use the big graph paper because we've done this so many times. So we have x, but instead of writing y up here, which is what we've done before, we'll write f of x. So you're plotting, for the x values, you're plotting the x values, and for the y values, you're just plotting these f of x values. So for functions, you need to start thinking of x and f of x. What the function has done, it's operated on the values of x. It spits out an output value that you call f of x. So you plot x versus f of x. So now we have the values of x here. We'll just go ahead and start. I guess I should have drawn it in the negative direction as well, right? Because what we're really plotting is, let's go -2, -1, this is 0, this is 1, and this is 2. And it looks like our y values go up to, let's just go up to 1, 2, 3, 4, 5, 6, 7. This is 7, this is 5, this is 3, this is 1. 1, 2, 3, 4, 5, 6, 7. And we have a little bit of a negative value here as well, so we'll go -1. So what we're going to do is plot it. -2, comma, -1. So -2's here, comma, -1. It's a little hard to write, but it's basically right around here. And then what we have next is -1, comma 1, which means -1 for x, +1 for y, which is right around there. Then we have 0, comma 3. So 0, comma 3, 1, 2, 3 is about right around there. And then we have 1, comma 5. 1, comma 5 is around there. And then 2, comma 7. 2, comma 7 is around there. Now, I know it's not perfect, and I'm actually really close to the board, so I can't really read them too easily, but it's a straight line. You can more or less see it's a straight line. So I'm just proving to you, even though we've done it a million times before with lines, that when you have something that looks like 2x plus 3 for your function, that's what we call a linear function. So you need to start using and understanding the terminology of algebra. That's much of what I'm trying to teach you here is the terminology in addition to the math, right? So when you see something like you have a linear function, it looks like this. It sounds very complicated. All it means is it's a line, right? So if you ever have something that asks you, once you learn about functions in your exam or something, and it asks you, here are 2 points, write me an equation of the function here. Well, it's exactly the same as writing the equation of the line that you've been doing over and over again. First, you find the slope between those points, and then you write mx plus b, or you can use the point slope form, y minus y1 equals m times x minus x1. And you basically do it exactly the same way. It's just that instead of saying y is equal to this, you say f of x is equal to this. So we're doing mostly terminology here, but from pretty much here on out, we're going to be talking about functions of x, right? So this is called a linear function. I want to go through a couple of additionals just to give you some examples of what other functions might look like. Let's say that we're going to take input values of x, and we're going to calculate what the function looks like if it looks like f of x is equal to x squared. Now the first thing is you should notice that this is not a line at all. I mean, the equation of a line is mx plus b, number times x plus number, right? But this looks nothing like that because you have an exponent here. So right away, you know that all lines should look like mx plus b. You should have that in your mind. This doesn't look like that, so it's not going to look like a line, right? So we're going to go ahead and show you how that looks right now. Now, just to keep it on even footing, we'll choose the same exact points, -2, -1, 0, 1, and 2, as values, and we'll stick them in here. So we'll take and operate on the first one. F of -2 is -2 squared. Make sure you stick the entire negative quantity in to be squared. -2 times -2 is +4. Here, we'll have a function evaluated at -1. Stick the -1 in there. -1 times -1 is +1. We'll take the 0 in there. We'll evaluate it at 0. 0 squared. 0 times 0 is, of course, 0. Switch colors just to break it up a little bit. We'll take f, evaluated at 1, is going to be 1 squared. 1 times 1 is 1. And then in 2, you can see the pattern here. It's just going to be 2 squared, which is 4. Now notice the interesting thing about this x squared function here. Even for the negative values of x, we ended up getting positive values on the output f of x. For the positive values, of course, we always get positive values. So the interesting thing is, because you have a function that's squared, no matter what the input is, if it's positive or negative, you're still going to get a positive answer. So let's take a look and see what this graph looks like, just to compare it. here. So we will go and look over here and see what this looks like. So let's say we have, here's -1, here's -2, here's 0, of course, and here's 1, here's 2. And let's say we have 1, 2, 3, 4, let's call this 5, right? Now let's plot this guy and take a look at what we have. -2, 4 means -2 way up here at 4. That's what it looks like at the beginning. Then -1, 1, -1, 1 is way down here. Then we have 0, 0, that's right at the origin. Then we have 1, 1, 1 over here, 1 up is right there, and then 2, 4 is up here. Now, it looks like you could just draw a little line, little line segments to connect them, like a little line segment here, a little different line segment here, different line segment here, different line segment here. And it does look like that at first glance, but if I had put more points in here, like if I put -1.5, if I put -0.5, if I put 0.5, if I put 1.5, or if I put like 100 points in there, in between all of these numbers to get a lot of granularity in exactly what it looks like, what you would actually find is the function would trace a path more like this. It would be a curved kind of deal that kind of goes and it just kisses the axis there and then it goes back up like this. It gets very steep at the ends here. This guy is not a linear, it's not a linear function. It's called a quadratic function. We're going to talk a whole lot about quadratic functions later on. So don't worry about it. I'm just giving you the name of it so that you can kind of get used to it, roll it off your tongue a little bit. But the idea of a quadratic function just means that you have x with a square power. Any function with x that has a square power, we call it a quadratic function, and they're pretty much always going to look something like this. Sometimes they might go upside down, but they're always going to be a smiley face or a frowny face like this, kind of doing this. Now notice it gets very steep up here and over here because everything's squared. So here when I start, if I would go to the next one, it would be 3, 9, because 3 times 3 is 9, or 4, 16. Or 5, 25. You see what's going on here? 6, 36, because you're squaring it. So as you get farther in x, it's getting really, really steep. So this thing gets really, really steep as you get just past and go into the positive territory or in the negative territory here as well. All right? So that's a quadratic function. Now what I want to do is I've illustrated by plotting points to show you, hey, this is called a linear function. You've already talked about it. It's a line. Here we have, we haven't learned much about it, but it's called a quadratic function. By the way, if you want to see that written down, it looks like this, quadratic function, right? But the point of this lesson isn't really to learn too much about this or too much about this. The point of this is just for you to get the idea of a function in your mind and have some practical examples of what functions look like. So what I want to do before we close the lesson is I want to illustrate what a few more functions look like, kind of a tour of what you might see some functions that might look like in algebra and beyond. All right, so here's some functions that we can talk about. We can say, we already talked about f of x is equal to x squared. We just drew it here, but just for completeness, I will go ahead and put it in its place. A quadratic function looks like this. It starts up high, it kisses the x-axis, and it goes back up high again, and you saw that by us plotting our points, just like we did a minute ago. Of course, we already talked about the linear function, which is just a line. Now, let's take a look at what this function over here looks like. F of x equals x to the third power. So it's not x squared, it's x to the third power. This is called a cubic function. And if you were to plot this, of course it's freehand, so forgive me a little bit. It's actually going to look pretty interesting. It's going to start down low. It's going to go kiss the axis and go through it, and then it's going to go up this direction. Right? Now what I want to do is I want to get all of these on the board, and then once I get them all on the board, I'm going to go back through them and kind of explain why they look the way that they do. But first I just want you to kind of get an idea of, hey, here's what a quadratic function, an x squared type function looks like. Here's what an x cubed function looks like. Let's get through them all and then we'll go and talk about them a little bit more. Let's say we have f of x is equal to x to the fourth power, because you can have these quartic functions, we call them. We got this guy right here, and so we can draw this guy. Now it's interesting as well. It's going to be really, 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 yeah, let me do it like this. Really, really, really steep, and then really, really, really flat, and then really, really, really steep again. Notice it kind of looks a little bit like a quadratic. It's just much steeper, and then at the bottom it gets really, really flat, and we'll talk about that later. I haven't drawn any numbers. I don't want to get into the details here. I want to show you kind of the overview of what these look like. Another one I want to share with you is important. F of x is going to be equal to 1 over x. All right, we'll talk about this later, but I want to just draw it for you. Right, here's x and there's f of x. Now this one's interesting. It actually is split into two parts. It goes really up high like this and then curves down. And then on the negative side, it goes like this. So you can kind of draw little arrows here if you like. I'll explain why it looks like this in just a minute. But that's what 1 over x looks like. This is a hyperbola. And then we will talk about one last one. Right? And the last one I want to talk about is f of x is equal to the absolute value of x. Right? What do you think that's going to look like? Absolute value of x is a kind of a triangle-shaped thing. It's a straight line. Sorry, I put a little curve in that. I didn't intend to. Let me try to draw that a little bit better. It's a straight line, as best I can do anyway. And then it's a straight line this way, mirror image reverse. And it has a hard, like a point right in the center there, a little cusp right there. Now, one little bonus one I'll draw, actually I'll do this on the last page, because I really want you to understand the idea behind a lot of this stuff and where we're going with this, right? Here's x. Here's a function that you won't learn until much, much later in trigonometry, at the end of Algebra 2 and also in trigonometry. It's called the sine function, sine of x. This is kind of a bonus. You're not going to use this too much now, but I want to show you that these functions can look pretty interesting. This function starts here, and it goes up, and then it goes down, and it goes up, and it goes down, and it goes like this forever. So in the reverse direction, it goes like this, and so on. It's a wave, basically. So just a little bit of a fun fact for you when you get into more advanced studies and you talk about radio waves, any kind of wave that you might study in nature, it looks like this, which is a sine function. Notice it passes the vertical line test just like any other function. You can only cut it in one place, but it goes up and down and up and down. So this is what a radio wave would look like traveling to you through space. Well, let's come down to earth a little bit and talk a little bit about these functions. This one makes sense because we already plotted it. And so it's doing this because we're squaring everything, and so everything's getting very, very large. This one is looking like this because it's cubed. So when you look at the positive values of x, it's just multiplying by itself 3 times. So if x is 2, then it's 2 times 2 times 2. If x is 3, then it's 3 times 3 times 3. If x is 4, then it's 4 times 4 times 4. So it gets really, really, really big, really, really fast. But on the negative side, notice it curves down like this because if you have -1, then it'll be -1 times -1 times -1. So negative times negative times negative will give you a negative value. It'll still get really big in the negative direction, but it'll be negative because it'll have, again, on the negative side, -4 times -4 times -4 will give you negative large number, for instance. So it's going to get really, really big in the negative sense, and that's why it doesn't quite mirror this. It kind of starts in the negative sense, and then it goes back up in the positive sense. Now this one is to the 4th power. That means it's getting even steeper than this because you're multiplying it times 4. So if x was 5, it would be 5 times 5 times 5 times 5. So it gets really, really, really steep fast. But in this region, it bottoms out so flatly because between -1 and 1, when you have decimals there, if let's say x was 0.5, then it would be 0.5 times 0.5 times 0.5 times 0.5. So in the decimal regions in there, you're multiplying by a decimal over and over again, so it cuts it down and gets it really close to 0 like a bathtub down here. That's why it gets so flat here. This one does it as well, but not quite as much as this one. Now this one's called a hyperbola because you're dividing by x. So when x gets really, really big, like 1 over, let's say x is 100, 1 over 100, it gets really close to 0. But as x gets really, really close to 0 over here, like let's put x is equal to 0.5, then it would be 1 over 0.5. Let's say x is 0.1, really, really close to 0. Let's say x is 0.000001. Then you say 1 divided by 0.00001, which gives you a really big number. So you divide by the small numbers, it gives you a big number. You divide by the big numbers, gives you a small number. Exactly the same thing happens over here, but with negative numbers. So that's why when you're dividing by the negative values of x, it does the same thing, but over on the negative side for y. And then the final one's the absolute value, because over here it makes sense. What's the absolute value of 2? It's just going to be 2. What's the absolute value of 3? It's going to be 3. What's the absolute value of 17? It's going to be 17. But over here, what's the absolute value of negative 5? If x is negative 5, it'll be positive 5, and so on. So any negative value you put into this function gives you a positive value out. So the point of this was not for you to memorize these functions. The point of this was just to show you just kind of a potpourri of what some functions look like. So what we're going to do is we'll be talking a whole lot more about these linear functions as we go through the class. We've already done that a lot. Then we'll be talking a lot about quadratic functions, because quadratic functions with the parabolas like this, they make up quite a bit of science and math, right? So we'll be studying that a lot. But along the way, we will get into cubic functions. And you may have some other hyperbolas and things like this. And then when you get on into advanced math, you'll have crazier functions that look like waves, right? But the point is for you not to memorize them. The point is for you to know what functions are. Every one of these functions passes the vertical line test. Slice any of these functions vertically, and they only get cut in one place. Even this one, it only gets cut in one place, so they're functions. So that brings me back full circle. A function is a mathematical machine that takes x values for input and outputs y values for output in a one-to-one correspondence, meaning for every value of the input x, you only get one value of the output. And when you plot that, then we say that it passes the vertical line test, and that's a function. So make sure you understand this. Follow me on through the rest of the lessons. We'll be talking about functions for the rest of our time together. So I want to introduce it here, and then we'll get to the following lessons where we'll talk about different types of functions and how to solve equations with functions and do all kinds of things, all of which are really important in all branches of science, math, and engineering.